All right, if you love space, you're going to love this episode. I got to sit down with Dr. Kevin Williams. He is the director of the Whitworth Ferguson Planetarium right here at Buff State. What an incredible conversation. We talked about space, stars, galaxies, black holes. We talked about Mars. I mean, it was just fascinating. And we're very lucky to have the planetarium here in Buffalo. He talks all about it. We talked about some other pretty cool things as it relates to the Earth as well. Really great guy, highly intelligent. I did my best to keep up with him, but I think you're going to enjoy it. As always, this episode is brought to you by my law firm, Richmond Vona Personal Injury Attorneys. We hope you never need us, but if you do, we got your back. And finally, look, if you're enjoying these episodes, these conversations, we really appreciate it if you can like, follow, subscribe, leave us a great review wherever you listen. Helps us keep these episodes free and keep them coming. So enjoy. Thanks for being here.
Thanks for having me.
I'm excited to talk to you. I was telling Brett before we started, I usually don't get intimidated by having guests on, but I'm a little intimidated just because I know how smart you are, and we're going to talk about things way beyond my comprehension. But I'm excited, so I appreciate it. And I figured, look, you're the director of it's the Whitworth Ferguson Planetarium, right here at Buff State. And you're somebody who I wanted to have on for a while. Brett knows that, and we finally we got to make this thing happen. And I figured I was like, where should I start off with them? But I would love to kind of go back to maybe when you were a kid, and if you could kind of talk about, where the fascination, with, I don't want to just say space because there's a lot more to what you do and what you've studied and your degrees, but you can kind of talk about your journey getting to where you are today.
Yeah, it's kind of funny you ask that because a lot of my students ask the same thing as we're just talking informally about what they're interested in, and I think it was just I grew up in the 70s and early 80s, and there was a lot going on with the space shuttle in the early 80s. I spent a lot of time playing in the mud and getting interested in mud and dirt and looking up at the stars, and so just kind of exploring I guess what you might call the natural world, and then I was really fortunate when I was thinking about college and what I was interested in. I didn't have any forcing from my parents like, oh, you should go into this career or anything like that. So I was able to explore. Actually, I applied to colleges for planetary science and also aerospace engineering.
Oh, wow. And
got into both types of programs. So I had to decide right up to the deadline for deciding on colleges and decide to go the science side of things. So that's kind of where it started, was that just being able to explore and play in the mud, really. And,
Do you think you'd still be where you are today if you grew up in this day and age with cell phones and social media and all that kind of stuff?
Wow, that's a great question. It's hard to say, right? But I think there'd be so much more information earlier, right, at a younger age, and it might have. I guess if I focused that on things like space, then I would have gotten into it more and more, maybe. But there would have been a lot more distraction too. So it's hard to say. I would hope that I would ended up in the same place.
Does it feel like a calling to you, almost for the lack of a better term? Maybe you don't call it that way or call it that. Jeez, that's bad. But you know what I mean? Is it hey man, I don't care where I was born or where I was from. This I was meant to do this.
No, not really.
No,
no,
okay.
I think it's I think it's something where just things worked out well to be able to be in the position I'm in. And, I had some delays in graduate school when my advisor left, and I had to change schools and things like that, which at the time seemed like they were, devastating.
Yeah.
But it worked out timing wise that other opportunities, the timing worked out, and, ended up where I am. And actually, I didn't start out planning to go the planetarium route. When I started at Buff State, I was, a normal faculty member, and then let's see, I guess 4 years into that, the previous director passed away sort of suddenly, and that's how I became the planetarium director. So, again, just opportunities kind of happened at certain times that led to where I am. So, I don't think it's any sort of calling. I'm just really lucky that how things worked out.
Yeah, it is weird how life works out, right? Mm-hmm. This thing happens and this thing happens and then this thing doesn't happen. And then you're like, okay, I'm glad this worked out this way. So what was it when you were a kid about either, like you said, the dirt, the mud, space, or the earth? natural sciences. What was it that really like drew you in?
I think maybe trying to understand how things worked, right? And thinking that someday, like, you could be an astronaut, or maybe be on the moon someday. And but I think it was really just trying to figure things out, and kind of getting back to your cell phone question. If I was growing up in a time with cell phones, I might not be playing in the mud, right?
Right.
Be online or something. So I think it's just that wondering how things worked, why things were the way they were. Actually, I was telling one of my students today, my high school physics class was what really got me interested in kind of the physics side of things, because during the class, well, first of all, I had a great teacher, but it was kind of one of those aha moments where it's like, that's why that happens that way. And, that's why that happens. You can actually explain it with equations. And,
right.
I just thought that was really cool.
Having a great teacher is huge, especially, I think that can make or break you in terms of whether or not you go down a certain path or not. And I sense that you take your role as a teacher very seriously today.
Yeah, I think it's really important.
Yeah.
You can't just deliver the material. You have to get the students excited about it and explain why they should care, right?
Yeah. And they got to see that you care.
Yeah.
Right. Like, 'cause they're not dumb. Like, they can tell, right? So talk to me about, what does the director of a planetarium do every day? Like, what is your life like? I mean, it's got to be interesting.
It's a combination of being a faculty member. So I teach classes, I do research with students, but on the planetarium director side of things, it's pretty much overseeing everything related to the planetarium. I'm really fortunate to have an associate director who does a lot of the work, because we have a lot of school groups that come in, a lot of private groups, in addition to our public shows. So she does a lot of the coordination with teachers, getting them in, and we actually have a partnership over the last few years with Buffalo Public Schools, so all of their fourth grade students come into the planetarium. Wow. All of their high school earth science students come in, and so that's just over 100 individual visits to arrange and work through, in addition to all the others. So a lot of it is coordination of when we're doing different events, working with her to plan our future public shows, trying to think of like what would be interesting for audiences, and then the administrative side of things, like when checks come in and getting those deposited and keeping track of finances and planning stuff. And a lot of the things like I joke with audiences, but on one of our projectors in the planetarium, it shows like north, south, east, and west, and it's been months now, but I keep telling audiences, you don't see a W for west because I haven't changed the light bulb yet. So there's that sort of technical side of things where it's our responsibility to change light bulbs with the projectors, and because it is a specialized piece of equipment, so it's not something that we could just put in a work order and anybody could do it. And it's planning for the future too, because one of our systems has these two powerful computers, and at some point they're not going to be working, so we're going to have to buy a new system.
Oh, geez, yeah.
And they're really expensive, so planning that sort of budgeting.
How does a planetarium actually work? I mean, I know it's like there's some really expensive equipment associated with this.
Yeah. So a planetarium, traditionally has been used to show the night sky and talk about stars and constellations and planets. But over the last maybe 20, 25 years, there's a digital aspect of it too. So some planetariums have either a digital system where you have some number of projectors. It might be one, it might be 6 projectors that overlap. But it uses software to show the night sky or other things. Other planetariums have just the more traditional, what we call a star projector, so it shows the stars and planets. We're really fortunate because we have a large donation from an outside donor where we were able to buy both systems.
Oh, wow.
So we have on the state side of when the facility was built, they bought the digital system, and then with the donor money, we were able to buy the non-digital system. So I like to tell people we have the best of both worlds because they both have their advantages. With the digital system, one of the advantages is we can rise off of the Earth and fly to other planets or fly to other galaxies even. but in addition to the astronomy side, we can bring in other sciences. So we have like more earth science related programs, and we're able to show what we call immersive movies. So imagine watching a movie in front of you as a rectangle, but now having it surrounding you. It's a much more immersive sort of experience. And some planetariums have even started calling themselves immersive theaters and things because there is a lot more you can do. And expanding outside of the science, one of the things that I really try to do as much as possible is collaborate with other students and faculty on campus to do non-science things. So, for example, we've done different things with theater and music, and film students have done like immersive movies of their own, and working with graphic design students and computer animation students to do things. So it's there's a lot of expansion over the last couple of decades from just astronomy.
Well, how do you? So you mentioned, I think, a couple of times that I saw online, like there's different shows, so to speak. Is that the right terminology?
Yeah.
Is it like at a museum when they're like, okay, we got to figure out which exhibits to put out, or like how do you figure out which shows to have running, and where do you find them? Like, I'm just like curious about how this is how it all comes together.
It's a combination of different things. So we try to do like every season, like a program focused on the night sky, and that would be something that we would put together ourselves using the software. But then there are these immersive films that run like 20, 25 minutes, and those are licensed through whoever produces them.
Sure.
And some of them are, they're using supercomputers to generate these things, and so they have different price points too.
Yeah, I can imagine.
So we try to figure out, a nice mix of different topics that would be interesting for audiences. And with those 25-minute movies, then we have time after that to either augment it with more information or also include looking at the night sky.
That's awesome. So when you have people in, and it might be different because if it's kids or adults, but what are maybe some of like the most common reactions from people? Because I got to imagine people are like pretty genuinely amazed after they go through the experience.
Yeah, it's a range of reactions, but I think sometimes people, when they are outside of the planetarium, it's smaller than they think it's going to be, because on the outside it's 43 feet across or so. Yeah. But once you're inside and the lights are down, it feels huge. So my favorite kind of reaction that audiences have, no matter what age they are, is that when we get to showing the night sky and we bring down the lights and then we bring them down all the way so it's totally dark except for the stars, that's when you get the the oohs and ahs. Yeah. And I like to say that one of the most important things we do, I think, is showing people what the night sky looks like with no light pollution. Mm-hmm. Because here in Buffalo there are lots of lights, so we see very few stars. But if you can get rid of all the lights or turn them off, you would see a few thousand stars and the Milky Way. And so people don't have that same connection with the night sky as people did a long time ago. Not just here in Buffalo, of course, everywhere. Most people around the world live in places with some light pollution. So again, having them see that view of the sky without any lights, and thinking about and talking about how people a long time ago had a connection with the night sky, and they were tracking things and coming up with calendars and stories and things like that. It showing them that instead of just talking about it is, I think, really powerful. Yeah.
Can you talk a little bit more about that? Because I think it's almost like I feel like and maybe it's because of the light pollution, that kind of thing, or now even we were talking about earlier, like everyone's attached to their phones. It almost feels like we forget to look up. You know what I mean? And I think like a lot of people, like once in a while you find yourself like maybe in the countryside or some place where there isn't a lot of light, and you actually do look up, and it's mesmerizing. Like for whether people are in a planetarium or they happen to find themselves someplace where they actually can look up and see the sky, what would you tell them to look for? Or like what do we misunderstand about the sky?
I guess how much there is, right? Because if you're here in the city and you might see 20 stars if you're lucky, and you're out in a dark area and you can see a couple of thousand, there's a lot more that you can't even see with your eyes. And, just thinking about how huge, not just the universe, but even just our part of our galaxy is, and thinking about how small Earth is compared to everything. There's, I guess I try to talk about when we're doing sky shows about the night sky, is that, there's all this information we learn from telescopes and everything, which is great. But even just with your eyes, you can look up and see a few thousand stars. You can see planets. If you're in a dark area, you can see the Milky Way, and even, some nebulae, some small clouds of gas and dust. And you're seeing that with your eyes. You're not looking at a picture. So you're able to have that connection with the sky that people have for as long as people have been around.
Is it true that when we look into the sky, I don't know if I'm going to say this right, but like we're kind of looking in the past?
Yeah, exactly.
Can you explain that?
I'll try. It's one of those things that's hard to wrap your mind around sometimes. So imagine that there's a star that you're seeing that's 10 light years away. And first of all, we have to remember that a light year is like a ruler. It's a distance, even though it has year in it. So it's a light year is how far light travels in a year. So if a star is 10 light years away, it has actually taken 10 years for that light to get from the star to us.
Whoa.
So you're seeing what that star looked like 10 years ago. Now imagine that there's a galaxy, 5 billion light years away. You're seeing how it looked 5 billion years ago.
And is it possible that star is not even there anymore?
Yeah, it's possible, right? So you're using that star that's 10 light years away. If that star died 5 years ago, you're seeing how the star looked 10 years ago. You won't know it died for another 5 years.
Whoa. Yeah, that's crazy to think about.
To blow your
yeah. Is there somewhere around Buffalo or not, that we can go to get a great view of the sky that's not all that light pollution?
Yeah, good question.
Yeah, so there are certain places around the world that are designated as dark sky sites. There are actually rules about how much light you can have, basically no light. The closest one to Buffalo is about 3 hours away. It's down in Pennsylvania at Cherry Springs. But there are dark areas closer, like if you go down to Allegheny or east of here, out in once you get between here and Rochester, there are some very dark areas. But if you wanted to kind of be guaranteed that there's no light pollution, Cherry Springs.
Okay. You mentioned, because we were talking about kind of like how small we are, which is like doesn't even seem like the best way to describe it compared to, like the galaxy or space. I mean, like how do you explain that? Like how small are we? Like how small is Earth?
I guess there are different ways of thinking about it, right? If you want to think about it in terms of size compared to other things. So Earth compared to the sun, for example, thinking about the diameter of the sun, so side to side, you could fit 109 Earths across the diameter of the sun.
That's
so
crazy.
The sun is huge, right?
Yeah.
Now imagine that the biggest star we know of is, the size of the planetarium. So imagine it's like 35 feet across. That's the biggest star we know of. The sun would be the size of a grain of sand. Wow. So, that's just comparing size of Earth to other objects. But in terms of distance, the distances are huge. It's hard to wrap your mind around. Like, showing diagrams of it don't do it justice. So I don't have a good way of explaining it. It's
well, let me ask you this. So like if you're teaching somebody, like a child, like, hey, I'm going to teach you like the basics of like how to understand space. Like, where do you start? Like, do you start with stars? You start with like, how do you walk through it?
I guess it would depend on the age, right? Because you don't want to start talking about light years and stuff with a 2-year-old.
Yeah.
But typically you'd start with our solar system, right? Our solar system, so the sun and the planets, that's like our neighborhood, right? And then you could talk about how there are other neighborhoods far away from each other. And when you look up at the stars, about half of the stars have a solar system, so they have a group of planets. But our stars, the stars we see in the sky, are just a a neighborhood, or you might consider it like a city compared to our galaxy. And the way I like to describe galaxies is if you think about the universe, so the universe is everything out there in space. If that's like a giant ocean, galaxies are like islands of stars. But our island of stars, our galaxy, has between 200 and 400 billion stars in it. And there are maybe as many as 2 trillion galaxies. Whoa. So, you're not going to be talking about that with a 2-year-old or a second grader even. No. But so I think it's starting slow and starting with local stuff, which would be our solar system, and then hopefully expanding on that and getting them interested in things closer to us first.
Like, how much do you think we actually know about the universe? Like, hey, we know 1% of what's out there. Like, or what do you think?
It's probably like 5 to 10%.
Wow.
Yeah, because you've probably heard of like dark matter and dark energy.
Yeah.
If you add those together, it's somewhere around 95% of the universe, and we don't know much about it at all. So,
can you explain dark matter, dark energy?
Not much, because we don't know a lot about it. Yeah. I'll take that out. But I mean, dark matter is essentially material that we call it dark matter because it doesn't give off energy that we can detect. But we know it's there because it has gravity. And so there are areas where you can see faraway galaxies, and the light from those galaxies has been curved as it comes from that galaxy to us. And that's how you know something is there curving that light.
Wow.
So in astronomy, it's one of those cutting edge sort of areas. So there's not a lot we know about it, but we're learning more about it. And then dark energy is more of a repulsive force, so it pushes things apart. But that's the limit of what I understand about it.
My brain is like in a pretzel thinking about this. It's amazing.
Well, as an undergrad, I was an astronomy and physics major, and I distinctly remember, I think it was junior year in an astrophysics course, and I forget what we were talking about, but I remember thinking my brain hurts just trying to picture all that. Right?
Well, you're telling me. It's amazing. What do you think? I mean, going a little bit deeper, when we're talking about the universe, or even just if we're glancing up into space, what are the things that, like, maybe when you're teaching your students or you're teaching anybody, that really blow people's minds? Like things that, like, every single time, no matter who you talk to, people are like, "What? Wait, what?"
It might be like the number of stars, like we were just talking about a minute ago. With just, when you look up at the sky, you see a few thousand of them if you're lucky, but how many we don't see. And then maybe another thing that blows people's minds, that's, again, relatively new in the last couple of decades, is discovering planets around other stars, so exoplanets. And right now there are around 6,000 planets that have been confirmed around other stars, and a few, 10 to 20,000 more candidates. And I think when you start getting into just students realizing that there are these other solar systems, and we're learning about what those planets are like, and are there some that are solid? Are there some that are have atmospheres? Is there water? Is it the right temperature for water? And it gets to the question of life. So I think that's one of those other interesting areas that people, when they start thinking about it and learning about the possibilities, it can get pretty interesting.
In your world, is and maybe there isn't a general consensus, but is there a general consensus about whether or not there's life on other planets?
I think, I'm not sure if there's a consensus, but I imagine there is, because I think the consensus would be, in at least my own personal opinion, is there has to be, right? Like when you start thinking about the 400 billion trillion stars, and even if half of those have planets, and even if a small fraction of those have conditions, you go through all these percentages, and they get down to really small percentages, but when you multiply that by the huge number of possibilities, you have some number. So I think there has to be life out there, but But then you can get into the discussion of, all right, well, what is it, right?
Right.
Is it very simple life? Is it intelligent life? Is it life that existed 5 billion years ago and is now not there? Or is it life that will be there in 5 billion years when we're not here? So you also have to think about the deep time thing, the billions of years of the history of the universe. So again, this is more of the personal side of things.
Yeah.
I think there has to be life out there. I think there's probably life in our own solar system too. Maybe below the surface on Mars, maybe below the ice on some of the moons of Jupiter and Saturn, but that would be very simple life. Think about like just multicellular ocean life sort of the stuff.
Wow.
Not Marvin the Martian walking around.
Yeah. This is going to sound like a really stupid question because it probably is, but do you have a favorite planet?
It's not stupid. A lot of people ask me that.
Okay.
And I do. It's Mars.
Okay, why?
Part of the reason I think is I've done research looking at the geology on Mars and working with students looking at the geology on Mars. But what fascinates me about Mars is that it's very Earth-like in a lot of ways. So there are old river channels, there are volcanoes and sand dunes and all these sorts of features we see on Earth. But it's also very different from Earth because the atmosphere, it's only like 1% the atmosphere of Earth, so it's much lower pressure. It's very cold. The radiation hits the surface. So you have that, I guess, familiarity of Earth, but also a very different hostile place.
How cold is it?
The average is like negative 150, I think.
Whoa. Okay.
The warmest it gets on Mars is around freezing, maybe a little bit warmer than freezing.
Wow. Are there seasons on Mars, like for lack of a better term?
Yep, there are seasons. Yep. So Mars, the axis of Mars is tilted very similar to the axis of Earth. So yeah, it has seasons.
What I know, it seems. I mean, I don't follow it too closely, but it seems like Elon Musk is like really gung ho about setting up a civilization on Mars. From what you've read or researched, if you have, how close are we to having people? I guess the first step, right, would be sending people to Mars, right?
Yeah. So I guess you have to kind of distinguish between sending people to Mars versus having a civilization on Mars. And I mean, in terms of sending people to Mars, we could have done that in the 80s. It's the technology existed. It's just you have to have the will and financial support to do it because it's a probably a 10-year sort of program to get there, and the political cycle is not 10 years, so things change, priorities change, and but yeah, we could go. The joke is kind of like we should be sending people to Mars in the next 20 years. We've been saying that for 40 years. Yeah. So we just have to decide that that's a priority.
Would you go if you had the opportunity?
Depends who's sending me.
That's a good answer.
Because with NASA and their international partners, their program is to send astronauts, bring them back, that sort of thing. With SpaceX and Elon Musk, they're sending people on a one-way trip. Which I wouldn't want to do.
Yeah, I would not either. Yeah. What would the journey to Mars be like? Like, how long would it take? What does that look like?
It takes about 6-ish months to get to Mars.
Wow. Going how fast?
25,000 miles an hour.
Whoa.
Mars is far.
yeah. Sounds like it.
I mean, with the Artemis astronauts and even with Apollo, it took 3 days to get to the moon, and the moon is a lot closer than Mars. So in terms of the journey, it would be long, cooped up in a small space.
Yeah, that'd be tough. Can you talk about Artemis for because I think a lot of people were following it. I mean, can you just talk about kind of your thoughts on the whole thing, what happened, just provide a little insight into the whole mission?
Yeah, so people probably realize just by watching Artemis 2 is that there was an Artemis 1 back in late 2022, and that was an uncrewed mission, so no astronauts, but it was a test of the rocket and the Orion capsule where the astronauts are. So Artemis 2, it was the first time since 1972 that humans have been out near the moon. And it's interesting to think about it in a historic perspective because Gene Cernan, he was the commander on Apollo 17, the last astronauts that went to the moon. When he left the moon, the thought was that people would be going back relatively soon, like within 10, 20 years. They knew that the Apollo program was ending, but nobody thought that it would be more than 50 years later.
Right.
And again, that gets back to the same thing I mentioned before about funding, but it was really important to have astronauts go out to the moon with Artemis 2 without landing because, again, being the first time that we had astronauts on the in the Orion capsule, testing out the systems, and not just testing out systems, but also procedures for doing things. At the same time as collecting data from the moon, they released some other satellites. So, but I think, in the bigger picture, I think maybe the most important thing that's happening with Artemis is it's getting people interested in science and engineering. And again, thinking historically, I don't remember the Apollo program because I was alive at the very end of it, but that inspired a lot of young people to go into science and engineering, and hopefully that'll help ignite that interest now, and not even just people that would go into it, but just being aware that it's happening and why it's important, and maybe inspiring other things like art and other areas that aren't science but might be inspired by it.
Right. Was there a space mission while you were growing up that, of course, like we were of the age where you do remember, that was maybe most inspiring to you? Or one, or even one, you could answer it that way, or even one where you're like, man, I don't know why more people don't talk about it. It doesn't get the credit it deserves.
I think one of the I don't know if you really call it a downside, but one of the things about the shuttle program is that there were so many of them that it got to the point where it was like, oh, they're launching again. They, after a while, they weren't even showing it on the news or live on TV. So it's kind of hard to pick one out in particular, but I think one of the the ones that comes to mind, it's actually a set of them. The ones where I think it was 5 times they used the shuttle to visit the Hubble Space Telescope, because when Hubble was launched, there was a problem with its mirrors, and so it wasn't showing clear images. They were blurry. So they had to design a way to fix it, and the only way to do that is to go up with the shuttle and capture the satellite and basically install contact lenses. And so they did that, then allowing us to get back these incredible images. But then they went up, and I think it was maybe 4 more times, to switch out equipment, add better instruments, give it more fuel, boost it up to a higher thing. So I think the ability to that was amazing, and it got some press, but I think it maybe didn't get as much as people it should.
There's a lot of space movies out there, and like Brett and I were talking about Interstellar before you came in, but I don't know if I want to go down that rabbit hole right now. That really messes with my brain. Is there one, or or a couple that you're like, wow, you watch it and you're like, okay, that's fairly accurate? Because like I know, like whether like this is, I'm not trying to compare it, but like when I watch like lawyer movies, like legal movies, I'm like either like this makes no sense, like this is totally off, or I'm like, wow, that's actually pretty accurate. Like, are there ones where you're like, these are pretty spot on?
Yeah. I think maybe The Martian.
Okay, cool.
Was pretty good. There were some things wrong with it, but I think what
Matt
was
Damon.
Yep.
Yeah.
So the biggest thing that bugs me about it is like, I assume nobody's going to be watching it for the first time now, but he gets blown away by some wind. The wind on Mars isn't strong enough to blow you away. But besides that, it was pretty accurate. Like the geology, how he was dealing with pressure and temperature were all pretty accurate. And actually read the book before seeing the movie, and it kind of had a connection because, well, first of all, Mars is my favorite planet, but also part of the area on Mars that he had to travel across was an area that I had looked at and mapped and studied in detail. So I kind of was familiar with that area, and it was, it was fun kind of reading about it and then seeing it in the movie, having done research on that area.
Again, I'm probably going to say this a lot. It could be a stupid question, but like you actually, like, it was a great segue because I was thinking, like, how, whether you're studying Mars or anything else, like, how do you, in your role now, like, how do you stay up on things? Like, how do you conduct research projects? Like, what's like the method by which you go through? Like I'm just very curious about this.
It's evolved over the years.
Yeah, sure.
So at Buffalo State, the focus is on teaching. So we, compared to what we call like a research university, like University at Buffalo, they have other research responsibilities. So with us, they call us scholars in the researchers in the classroom. Mm-hmm. So we're expected to teach and do research, but involve the students in the research.
Oh, cool.
So my experience doing research and keeping up on things has been by having students work with me on those things. So as I was mentioning earlier, the Mars research, that's been involving students in it. We've done research in the Western New York area using ground-penetrating radar to look at objects beneath the surface, but that's been involving students doing that, and other projects too. So the way I keep up with things is through my students.
What kind of research did you do? And I'm curious here a little bit about what you're looking for underneath the surface of the Earth, because we've been talking about up, not down.
Yeah, it actually started before I came to Buffalo. I was doing a research position at the Air and Space Museum in DC, and my supervisor there was working with a company developing a ground-penetrating radar instrument for Mars, and so my role in that was testing out a prototype in different places on Earth. And so that got me into using that type of equipment. And then when I came to Buffalo, I was able to buy some of that equipment. And so locally, we've looked at things like old cemeteries where you have, maybe burials from the early 1900s that no longer have headstones, or they probably didn't ever have a headstone, but there might have been a wooden cross that is no longer there. So you have a cemetery that has an area that looks like there are no burials, but they are pretty sure they're there. So you can use the GPR to show where the burials are.
Wow.
Because it's detecting the disturbed surface. Yeah. We've used it a lot with burials, but also at Art Park, they were trying to figure out where an old time capsule was that was buried, and we were trying to find it using the radar because the time capsule was in a car that they buried.
Really? Yeah. Did you find it?
Well, where they thought it was, we spent most of the time looking there, and it wasn't there. And then as we were running out of time, I think we found where it was. Not that they were going to dig it up or anything, because there are environmental issues with a car buried below the surface, but just they wanted to put like a marker there or something. So we maybe 90% sure that we found it.
Wow. Where was the time capsule from? Like what year? Do they know?
I should know this. I think it was late 70s.
Wow.
Maybe.
I would love to see that. There's something beautiful about keeping it underground though. But I bet there's some wild stuff in there. I didn't expect to talk about graves today. Like that's awesome. I do have to take you momentarily back up to space because Brett would be very upset if I didn't ask about black holes. Mm-hmm. Can you explain?
Please
black
share.
Holes?
Please.
Yeah. Please explain black holes like we are children.
So first of all, there are two types of black holes. There are what are called stellar black holes, where you have one star that dies and leaves behind a black hole. And then there are supermassive black holes, and those are like, say 5 billion times the mass of the sun.
Wow.
Those are the ones that are like at the centers of galaxies. But the way that you form a black hole is when you have a massive star. So when the sun dies, it won't leave behind a black hole. But if you have a star that's maybe 10 times more massive than the sun, when it dies, it's going to create a supernova, so a big explosion. But as part of that, you also have a collapse of the inside of the star. And by doing that, you have this material that used to be part of the star that's now compressed together so tightly that it has a really, really high density. So it has a really high gravity. So a black hole is just an object that has really, really high gravity, so much that light can't escape from it. So it kind of pulls everything in toward it. And the reason that light can't escape is that to escape the gravity of a black hole, you have to travel faster than the speed of light.
Whoa.
So you can think about it as the gravitational pull of a black hole being more than the speed of light getting out.
And physics has proven that's not possible, right? To travel faster than the speed of light?
Right, yeah.
Okay.
Not yet.
But it's interesting because there have now been images of black holes, but black holes didn't give off energy. So what you're actually seeing in the images is material kind of spiraling around the black hole that some of it ends up getting pulled into the black hole. And as it's coming together and spinning around, it's giving off heat. So you're seeing that. You see other sort of these jets of X-rays being emitted out of like a north and south pole of a black hole. So there's a lot that we've learned about black holes in the last 20 years or so that for a long time, black holes were just theorized. And then they started discovering them.
And we know the location of them.
Some of them.
Some of them, right? Yeah. Is there ever a risk of, like, say, a spaceship going like too close to a black hole, or
in the movies?
Yeah. Okay. Fair enough. And if that actually happened, and you got too close, like, what would happen?
So imagine this. The way it's described sometimes so first of all, the black hole itself is like a solid object, but there's an area around the black hole where anything closer to the black hole or in that area would get pulled and basically become part of that black hole. But there's a limit. So inside the limit, you get pulled toward the black hole. Outside the limit, you can escape it. That limit is called the event horizon. And the reason I'm saying that is, all right, now you have a ship, but let's make it simple. Let's say you're just out there without a ship.
Yeah.
If you go beyond the event horizon, your feet now get pulled toward the black hole at the speed of light, while the rest of your body is outside of it and slowly moving into it. And so the term that's used is spaghettification, because your body would be pulled like a piece of spaghetti.
Wow. Oh my God. Is it true that time actually slows down when you get close to a black hole?
So yeah, with special relativity, like when things start moving near the speed of light, time moves slower, lengths get longer. And so it's great for science fiction, right? Because you have astronauts that are traveling and then they come back and 500 years have gone by.
Yeah.
So yeah, it's
yeah. How
weird.
like that's because that's one thing that always that's what happens in Interstellar, right? How long is he gone for? Do you remember?
They go to the surface of a planet and they come back, what would be a couple hours later, and the guy's like 30 years older. Kind of thing. Like every minute was 10 years or something to that effect.
Yeah, I think you may have just did this, but like, how do you dumb that down and explain that for us? Like, what is the concept behind that, anyways?
How to explain it? It's because, and again, this is all equations. So if it actually works that way, who knows? But as you're traveling close to the speed of light, so faster and faster, distances get longer. It's all about reference frame. Sure. So if the distance is longer, it's going to take you longer to travel that distance, which means that time is also slowing down. And it's kind of time, speed, and length are all related to each other. That's one of those things that started making my mind hurt in college.
Yeah.
So that's the best I can do right now.
Yeah, that's fair enough. That is.
I have a quick question about Hubble too. You mentioned Hubble. Like, how much has Hubble helped you advance your studies, or the study of physics and astronomy in general? Just to understand it.
Yeah. Personally, it hasn't helped me because the research that I do is more looking at the geology of planets. But in terms of astronomy overall, the Hubble Space Telescope really revolutionized our understanding of space because it allowed us to see details that we couldn't see before. Now, Hubble's been up for more than 30 years now, and you've probably heard about the James Webb Space Telescope. That's like the next big advance in resolution. So with Webb, it's kind of 100 times more detail that we can see.
Wow.
And so we're in the we're in the process of seeing those results, and the Webb Telescope is again creating this new kind of revolution in our understanding of space.
If you had unlimited resources and you could, like, say, fund one research project that you could be at the forefront of, what would it be?
And I guess if time wasn't an issue, I think trying to do like an in-depth study of one of the moons of the outer solar system. So maybe Europa, which is a moon of Jupiter, or Titan, which is a moon of Saturn, or Enceladus, which is around Saturn. And the reason there is because there's interesting things that happen at the surface or below the surface with, at the surface it's cold, so you have frozen water, but below the surface, liquid water. And then you get into the whole question of could life exist there and what would that be like? And so I think either that or I always have to go back to Mars.
Yeah. Is there, what's a project maybe that you've worked on with your students that you're most proud of?
There are a bunch, but I think the maybe the one that has more pride with it is I had a student. She was actually from Pakistan, and she was here as an international student, and she got involved with some research with me looking at Mars and studied a certain area. And as part of that, you have to like learn about Mars, learn about the images, learn about how to process the image and interpret them. But she was able to create basically a map of a certain area and talk about what she thought had happened there. She presented her research at a national geology conference. She got a summer internship at the Air and Space Museum in D.C. And so I think I'm really proud of that because it was something that gave her opportunities, not just on campus, but like I said, at that national conference and then a summer internship.
Yeah, I was going to ask you what type of, I don't want to say careers, but what type of positions or careers your students typically end up in? Like what are people doing with their degrees?
It's all over the place.
Yeah.
A lot of our students go into teaching, which I think is really important, especially in the sciences. And I think that's something where their experiences doing research and maybe presenting research at conferences is something that can actually help them be even better teachers because they can maybe do that sort of thing with their students, at least talk about their experiences. Some of our students go into either like environmental or consulting sort of companies in the area. There's some government agencies like Corps of Engineers or other either local or state agencies that they work with. Some of them don't go into science at all. They might just be getting a degree in geosciences because they're interested in it, but then decide they want to do something else. So it's really all over the place.
That's cool. We talked a lot about space, but I know we didn't talk too much about the Earth. We talked a little bit. What do you think? I asked a similar question, like what are like the biggest misconceptions when people, look up into the sky, if we're talking about the ground underneath us, like what are things that, blow people's minds maybe when you talk to them or teach them about it?
I think how much time there has been. So like Earth history and, Earth is around 4.5 billion years old. So picturing that, and there are different ways of doing that. You can do it with like a timeline or like set it up on a football field, those sorts of things. But to think about how much history there has been on Earth, how much of a small fraction of that has been advanced life, how much of a smaller fraction has been humans, and then, our lifetime. And, thinking about that kind of blows your mind, but then also thinking about, all right, what are things going to be like in the future?
Right.
Like, a million years from now, humans aren't going to be here. So, what is Earth going to be like? What's life going to be like on Earth? A billion years from now, what is it going to be like? So that's something that blows people's minds a lot, I think. In terms of misconceptions, or a lot of misconceptions, I think the one that I like to kid people about is, south is not down. Because we talk about it like, going down to Florida or something like that. But we just think about it being down because you think about a map or a globe. South is down, but it's not really down. It's over there.
Well, the Earth's flat, right?
Well,
I'm just kidding.
I can't admit that. But,
oh man, I had something I was going to ask you, and I totally lost my train. I should have made that stupid joke. Totally lost my train of thought. I was going to ask, because this is where my head went. Are dinosaurs in your jurisdiction?
I mean, their remains are rocks now, so it is. But that's a part of geology, like that's paleontology.
Right,
so it's not really my focus. But I could make stuff up. No. What was the question?
There's no question.
Okay.
What do you think about the, and like the future of Earth? Like, I know we have no idea of really knowing, but like, I don't know. What are your thoughts on it?
Earth is a planet. I think an interesting thing to think about is, the planet itself doesn't really care, if you want to, what's the word? Think about Earth as a living being. Earth doesn't care what we're doing to it. But when you think about like climate change and other things like pollution and things like that, that's affecting us and other species. The Earth is going to do what it does. It's just, it's its own system, and things change. And in the future, things are going to keep going the way they're going. Like, there's plate tectonics, so the continents are moving around, and that's going to continue to happen. So if we come back in 100 million years, the continents are going to be in a much different place than they are today.
I asked somebody else this recently. So he's very interesting. His name's Anthony Greco. He's from the Buffalo History Museum. Mm-hmm. And I asked him the same question I'm going to ask you. If you had a time machine, I'm going to ask you a little bit differently though. If you had a time machine and you could go either forwards or backwards, which way would you go? And maybe like how far back or how far forward would you go, and why? You
should have given me that question ahead of time.
No, it's more fun if you have it in the moment.
Right. Wow. Picking just one, it's hard. I think the easy answer, or the easiest, is I think I'd go back in time to witness some important event, or be able to talk to somebody that some historical figure. Because we don't know what the future is going to be like. So it would be interesting to come back in a million years, but maybe you'd get there and then you'd be immediately eaten by some new creature that doesn't exist today.
So when I do this once in a while, like you're having beers with like your friends or something, and this comes up, I'll be like, and how about this? You can't die. So you have like some sort of invisibility cloak, or just some invincibility cloak if you want to be seen, and you can put yourself wherever you need to be. Like whether it's like you said, talking to a historical figure during a very significant time in history, or going to the future and witnessing some sort of like event. And then you have like your one buddy who's like, I would just go back to X date and know the winning numbers to the Powerball and then just come back. And I'm like, fair enough.
Yep.
All right. So I want to talk a little bit more as we're kind of winding down about the planetarium, because it sounds like we're very lucky to have it, and more people, not just children, I think could get a lot out of it. So what are maybe things that you want people to know about the planetarium that you think that maybe the public doesn't know?
I guess first that we exist, because part of the issue is always just, how do you market to get to the people who would be interested? But we, in terms of a question we get a lot is when we're open. So we have our public shows most Friday and Saturday evenings, but private groups come in almost any time. So we've done mostly school groups or other private groups, scout groups. We've done wedding proposals. We've done one wedding. So birthday parties. We do a lot of birthday parties. So it's, I think the thing I would encourage people is, just reach out to us if you have questions. And I guess maybe the second thing is that because we're a planetarium and not an observatory where you'd be looking through telescopes, it doesn't matter what the weather is outside.
Yeah. Good call. Yeah.
So, because in the past we've had people that didn't show up because it was cloudy outside. It's like, well, it's always clear in the planetarium. So,
That's awesome. And what I know we talked about earlier. What shows do you have going on now?
So right now we're actually kind of focusing on human spaceflight. So our Friday night show is an immersive movie called Astronaut. So about what it takes to be an astronaut, followed by I think it's maybe 10 or 15 minutes about Artemis too, and then ending it with a brief look at the stars, and then Saturday night is similar, but it's a different program. It's called Explore, and it's about, if we're going to be sending humans to Mars someday, what are some of the technologies and research that we're doing now to prepare for that. Again, followed by Artemis 2 discussion and stars. So last Friday was interesting because that's when Artemis 2 splashed down, and so the astronaut program was between 7 o'clock and 8 o'clock, and the splashdown was like 8:10 or so. So they were able to show the live stream of the splashdown to the audience as it was happening.
That's amazing. Yeah. That's awesome. I think I even saw on the website that for private parties, if you're all adults, you can arrange for, we'll call it a beer cart. Is that fair?
Yeah. So some of those private events.
That's awesome.
We've had some adult birthday parties, and through the caterers on campus, you can do a bar basically.
I want my birthday next birthday party there. I'm not even kidding. So. Last question. Let me ask you this before I ask the last question, because it's going to be a playful question. But is there anything that we didn't talk about that you're hoping that I was going to bring up that we didn't have a chance to talk about?
Ooh. No, I didn't really have any preconceived idea.
Nice.
Yep.
You're just being nice.
Well, I have a question.
Yeah.
Armageddon, the movie with Bruce Willis, where they fly up and blow up the asteroid that's coming to hit the United States or the world. Real or not?
The movie was real, unfortunately. No, it was. That's not how an object coming to hit Earth would be dealt with.
Do you think there's a possibility that could happen?
Yes.
Like, is there enough stuff out there?
Well, I guess that's something that is good for people to know about, is that with all this stuff in space, there's a lot we don't know about. And you look at the history of Earth, you look at other planets, we've been hit by objects, big objects, every now and then. We're hit by little objects all the time. It's likely that there's some object out there that if it hit Earth could cause a huge extinction event. So the trick is finding it so you have enough time to do something about it. If we find it and it's going to hit us next week, too bad. But NASA's actually been doing some, and other countries too, but they had a mission a few years ago called DART, where they had a spacecraft that hit a small asteroid with an object and meant to push it onto a different path. And so that would be what you would want to do, is just have enough lead time, you nudge it so that by the time it gets to Earth, it doesn't hit us. With Armageddon, you blow up a rocky object with nuclear weapons. Now you have all these radioactive rocks hitting Earth. Not the best solution.
Not a great idea. All right, last question, and I'm not going to put you in a tough spot, so I'm just going to say, in a hypothetical world where aliens do exist, if you had the opportunity, would you want to talk to them?
Absolutely.
What would you say?
Help.
What do you want their help with?
Lots of things, all right, like energy, food supply, pollution, climate, those sorts of things. But then also, like, what have you learned by visiting other places? So like when one of the classes I teach is like basically an introduction to solar system, and we talk about life elsewhere and thinking about aliens coming to Earth, or meeting aliens someday.
Yeah.
You want them to be the friendly aliens, right? You don't want them to be alien from the movie.
Exactly, yeah.
Because you might not even get to ask them a question; they might just eat you.
Yeah. We want the friendly aliens who are like, "Hey guys, enough is enough. We're coming here to help you.
Yeah.
we let you go along by yourselves for too long. We're here to help now."
Yeah. So to answer your question, I think if there's an alien species that has the technology to come to Earth, they're much more advanced than we are. So trying to learn things from them.
Awesome. Well, this has been great. Thanks for doing this. I appreciate it. This was a lot of fun.
Yeah, it's a lot of fun. Thanks for having me.
Appreciate it. All right, everybody, that's a wrap on this episode of Angles. I appreciate you listening in as always. And look, I just have one small favor to ask of you. If you got value out of this episode, please go on, whether you follow us on Apple, Spotify, YouTube, wherever, like, subscribe, leave us a review, share this with your friends. Doing this makes the podcast more visible, ensures we can keep running this, we can keep getting great guests to tell these great stories. So again, if you've gotten any benefit out of this, share with a friend, your family member, whoever. We really appreciate it. Thanks as always for listening. We'll see you on the next one.